Hey everybody, I was working on a Pac-Man PCB. Oh my gosh, look at, can't really see that. And it had some problems, and so I started pulling out the proms here to read them or to verify they're good. And if you can see that, the legs just started breaking off. These things are frail. They've been burnt up with some, just over time, getting tarnished and stuff. So what I figured we'd do is, since I need to replace them with 2532s, I would make a quick video of the EMP-30 with the Windows software and finish up that little series there. So I'll be right back. We're going to program some 2532s. These are, if you can see that, nope. These are 2532s. There we go. 2532A. I have 3 of those. I have two 2532s, and then I also have an HN, so probably Hitachi or something like that, 46 2532. So we are going to use those and burn some Pac-Man ROMs. Be right back. Alright, hopefully the volume is okay here. The first thing we're going to do is, well, actually we powered on the EMP-30 device, or actually you don't have to power it on. The EMP-30 will get turned on automatically after you click the open up the software. Let's zoom in just a little bit. Right there. The nice thing about this is you can change the logging level. So I have it log level set to verbose, so we can actually see a little bit more of what's going on. And let's go ahead and clear that. And we want to choose our device. Now you could see that it was loading all the devices. And now the one thing about this is you can't just type in here and search. You kind of have to know, let's say we want to blank check our Hitachi. I think we have to choose EPROMs, and then let's see here, Hitachi HN. I don't even see an HN25. HN46. Nope. No, that we ran into our first problem there. So the HN actually isn't, the HN46 2532G is not on here. So we would have to choose like a regular, well, Intel I don't think made a 2532, so we'd probably have to go with, look up the spec sheet and see if it's the same as a TMS 2532. So we'll put that one to the side for right now, and we'll choose 2532. It says it selected the device, and what we need to do is we need to open up the file that we want to burn, the desktop Pac-Man, and we'll do 5E first. And that's a lot of clicking OKs there. And we're going to put our 2532 in. Let's blank check it. It is blank, and now let's program it. And you can see our buffer, our checksum of our buffer is over here, 41671, and our device is FF000, which is, yeah, that's, I believe that's correct, isn't it? Yep, FF000, that's the checksum for a 2532 or 2732 blank chip. So we'll hit program. Looks like it blank checked it again as part of the programming option, so you can see exactly what's going on here. just says busy. And this looks like it's going to take a while to program this. So instead of sitting here like I did before and timing it, I'll just pause it, and then we'll come back when it gets closer to the progress bar, gets a little closer. Alright, it's still working. The one thing I don't like about the Windows options is you don't get to see what the voltage is. So we don't know what voltage was selected for this chip. We're completely kind of in the blind as far as that goes. It is kind of a decent user interface. There is no search on the device list, so you kind of have to click and filter through it, which is a little bit annoying. I do like this log level here. And then it looks like it did verify it. So it shows you that it took 3 minutes and 26 seconds basically to program that. And to verify it, it only took 329 milliseconds. So the verify was pretty quick, but the actual writing was pretty slow. So maybe we'll do one more and just see what we get there. So I'm gonna take that one out, and we will program another 2532. And it looks like it part of its process is to blank check it, so I'm not going to blank check this one. We're just going to open our file, and we're going to open 5F. That's a lot of clicking of OKs there, but whatever. And then now we're going to program. Oh, to see it failed. And why did it fail? Unable to calculate. Blank check complete. Says it's blank. Huh. It's not programming it. That's kind of strange, isn't it? I wonder why that is. TMS 2532. It said, am I missing something? It says unable to calculate checksum. Let's clear the log here real quick. And that is the correct checksum for a blank blank chip. Actual data, device address, actual data expected 00. So it's trying to, what it looks like is it's trying to write that first byte, and what usually happens is it tries to write a byte and then it verifies the byte. And so if we look at our buffer, it says the first byte is actually 00. It says device addressed, actual data, FF, expected 00. Okay, so yeah, so it's trying to actually program that first byte, and it's still seeing it as being FF, which is blank. And it was expecting 00, and so that kind of shows you that's interesting information. I mean, it lets you know potentially what exact address on the chip it could not program, and what data it saw in the verification process. That's kind of nice, actually. I haven't seen that before on other ones. Maybe it is possible to see that information. I haven't seen it before. So let's go ahead and try to program this HN2532 with the same settings. So we're just going to use the TMS 2532, which should work, I think. We're going to blank check it. Says it is blank. We're going to program. Alright, and now this one looks like it's programming it. So it's, you know, writing to address, you know, the first byte, and then it will verify that byte, and then go to the next byte and verify that byte. That's typically how most programmers work, or most programming algorithms, I guess, based off of what I've read so far. Alright, so we're going to program that. I'll let that run for a little bit, and then I'll come back. Alright, so the chip finished up there. One of the things you can see down this way is you can actually see the file name that we're writing. Let's see, it said it took 3 minutes 26 seconds right there. That looks like almost identical. I cleared the log, unfortunately, so I can't scroll back. I have to look back through the tape, but that looks pretty consistent. So if it's using the standard programming algorithm, which is 50 millisecond pulses to actually program it, you basically take that 50 milliseconds and times it by the number of bytes, and you have how much time you're supposed, you know, it should take to program it, as long as it verifies correctly after each one. And then the buffer over here, your checksums, you can see it matches. So the file in the buffer checksum matches the device checksum, which is nice, and it's doing that automatically, which I think it wasn't doing that with the DOS software. The DOS software, I think we had to actually hit a checksum button to actually get it. So there's some benefits of using the Windows software. This is version 1.6, which I believe is the latest. I don't think they made any other versions after that. Let's see if there's anything else I wanted to show here. We could verify it again. Obviously, verify and read operations are pretty fast, so that's not a problem. Honestly, that happens a lot faster than the GQ, unless you have the GQ speed setting maxed out. So like, I've come to figure out what that means a little bit more too, but I'm not probably going to go back to that. You got like some help functionality, device, file. You know, you can edit the buffer. See our preferences. We have different, you know, preferences here. So I think that's all I'm going to show. Let me see if I shut this down. You can see that the fan actually went off. So the EMP-30 power is actually controlled by whether the software program is actually running or not. So if I click on this, it says it's attempting to communicate with the EMP-30, and then that powers it on by itself, which is kind of nice. And I was hoping that it would prompt me. Maybe it's under preferences. Oh, we can actually say don't ask for confirmation when loading a file, so we'll check that. Always set file type. Alright, I think that's good. Alright, so let me come back and do one more with a DOS with the DOS system. I'll be right back. Alright, so I have the DOS up here. Actually, you can't see that. Whoops. There we go. Kind of difficult to see, but anyway, EMP-30. And that's going to actually turn on the EMP just like the Windows would, or it should anyway. After I press continue, it says communicating with it, and there you can hear the fan come on at that point. All right, so I'm going to zoom in just kind of on the top part there a little bit. So the first thing we want to do is select our device, and we're going to go to Texas Instrument 2532A. That's our device that we want to do, and it's just telling us what modules that we need in there, the DIP48 and the EMP 301. Does it say that? Nope, just says DIP48 is needed. and we can select our device. Oh, we already did that. Let's verify our device. Or no, blank check. Verify the device is erased. Oh, says it, I don't have it locked in. Let's try it again. Okay, so it is erased. So we need to load our file. This is where, it says here we have to specify it with the option V over here first. So this is where it's, Windows is a little bit more user-friendly. We have to hit V, and then it gives us some options. We want to hit F1, go to our parent directory, go to Documents, my compact, Desktop, Pac-Man, and we're going to load up 6F. And now we have to actually, after specifying the file name, we have to actually hit number 8 to load the file from the disk. And then it asks us, check your buffer and all those settings. But I think our buffer's right. Yeah. And then it says, okay, we got 4,096 bytes loaded. And now we want to program our device. Now, just to recap real quick, the things I like about this over here is it's actually telling you the voltage. So we see that it says this is a 21 volt chip for VPP because it's a 2532A. And you can see the programming VCC is 5 volts. And we also get to see that programming algorithm, which I like. So in the Windows version, we didn't get to see that information, which kind of sucks. And you can actually change it. Now, I did check the data sheet, and you cannot program this chip, as far as I can tell, faster than the standard 50 millisecond pulse. So we're just going to leave everything default and program the device. And I'll pause and wait for it to be finished, but it does give you a little bit of a progress. Eventually it'll say it programmed the first device address. And I guess how many addresses? There should be more than 8, right? So it says device address X100H. So you would think we'd go all the way up to 100. But I don't know exactly. I haven't figured this part out yet. But I'll be back. Alright, so it says it's done. We can press any key to continue. It went up to 10. So it was like 10 times 100 hex, which would be 1,000, which is 1,000 hex is how big the chip is. Now at this point we have to actually, you can use a cursor to kind of move around a little bit with the mouse, but we want to do a buffer checksum, and then we want to do a device checksum. And so both were pretty fast, and you can see that it matches, but that's something you have to do manually. It doesn't automatically calculate that checksum for you, which is kind of interesting, I thought. But anyway, I think that was Pac-Man 6F, so I'm not going to show too much more. Maybe put this in the game and see if I can actually get these Pac-ROMs to work right there. Okay, I have the chips all back in the board, all programmed, so that definitely took quite a while to get all those programmed. The only thing I had to do to fix this board actually is I had to fix a couple of the edge connectors there, the card edge, and I think replace the Z80. I think the Z80 was bad, so it's powered on. And looks like we got something. Coin it up here. I don't know if the sounds a little funky. I might put it in a game and see what it sounds like. Alright, that's it for this video. Alright, see ya.